Wandering chemistry. In the previous lecture, we learned about group displacement law, that is first and second law. First law is about alpha emission and second law is about beta emission, and we see the example of 1 alpha and 2 beta emission. Again, we see the next example of this process, that is 1 alpha emission and then 2 beta emission. For example, U sub 92 sub 238 after alpha emission change to TH sub 90 sub 234. Again after beta emission it changed to PA sub 91 sub 234, and again after beta emission it changes U sub 92 sub 234. So here U, that is first and the last, is isotopes, and second and third is isobars, that is U sub 92 isobars. Now see the third law of group displacement law, that is beta plus decay. When an unstable nuclei decays by emitting positron, that is beta plus, the daughter element has an atomic number reduced by 1 and the mass number remains unchanged. Thus, the daughter element is displaced one position toward the left in the periodic table. Thus, this can be shown by example. X sub z sub a change to y sub z minus 1 sub a plus e sub plus 1 sub 0. Here e represents beta plus, that is emission of positron. So let's see its example. For example, n sub 7 sub 13 change to C sub 6 sub 13 plus E sub plus 1 sub 0. And next example is O sub 8 sub 15 change to N sub 7 sub 15 plus E sub plus 1 sub 0. And the next example is Na sub 11 sub 22 change to Ne sub 10 sub 22 plus E sub plus 1 sub 0. So this is the example of beta plus decay. Now let's see about the mechanism of gamma decay. Just an electron in atoms have definite energy, so have the nucleon in the nucleus. When a nucleus undergoes a radioactive transformation by emitting alpha or beta particles, the residual nucleus is left in excited state. The excited nucleus goes to the ground state by releasing the excitation energy in the form of electromagnetic radiation called gamma rays. For example, when magnesium or Mg12 sub 12 sub 27 emits beta minus, then it comes to the excited state, and again it emits now laws of radioactive disintegration rate and disintegration constant. The radioactive disintegration is found to obey the following two laws. First, atoms of all radioactive elements undergoes a spontaneous disintegration to form fresh radioactive products with the emission of alpha, beta and gamma rays. Second, the rate of radioactive disintegration, that is the number of disintegration per second, is not affected by environmental factors like temperature, pressure and chemical combination, but depends on the number of atoms of the original kind present at any time. Now, expression for radioactive decay. The decay of a radioactive element is a random process and is not influenced by external factors such as temperature, pressure, etc. The rate of decay is directly proportional to the number of atoms present, following an exponential law. The rate of decay decreases with time. Kinetically, the process is a first-order reaction. Consider a radioactive element A disintegrate to give the A change to product. That is, the rate of disintegration will be minus dN by dt proportional to N.